Well, let me tell you something that has been bothering me for a long time. You go outside on a clear night, you look up, and there are stars everywhere. Thousands of them visible to the naked eye. Billions more behind those. And behind those billions, billions of galaxies, each containing hundreds of billions of stars, most of them orbited by planets. The numbers are so large they stop meaning anything. And yet, when you really listen, there is nothing, no signal, no message, no visit, no evidence that anyone, anywhere, has ever tried to reach us or succeeded in going anywhere at all. Now, your gut tells you that is wrong. Your gut says somebody should be out there. With all those stars, all those planets, all that time, somebody should have figured it out by now. Somebody should have built a ship, crossed the distance, and shown up. But here is something I want you to think about carefully. Your gut evolved to dodge predators on the African savanna. It is very good at estimating whether a rustling bush contains a lion. It is not designed, not even a little bit, to evaluate the structure of spacetime. And when you sit down and actually run the numbers, when you do the physics honestly, you hit walls. Not engineering problems, not things we just have not solved yet. Structural limits, walls built into the laws of nature themselves. And I want to walk you through them because I think they are some of the most beautiful and terrifying facts about the universe we live in. You see, the first wall is distance. And I do not mean distance the way you normally think about it. I mean distance at a scale that breaks human intuition completely. The nearest star to our Sun is Proxima Centauri. It is 4.24 light years away. Now, a light year sounds like a convenient unit, almost cozy, but let me tell you what it actually means. Light travels at roughly 300,000 kilometers per second. In 1 year, it covers about 9.5 trillion kilometers. Multiply that by 4.24. That is the distance to our nearest neighbor. The closest star, the one right next door. Now, the fastest object humanity has ever built is the Parker Solar Probe, which moves at about 692,000 kilometers per hour. That is fast, unimaginably fast by any human standard. And at that speed, the trip to Proxima Centauri would take 6,600 years. Think about that. That is longer than all of recorded human civilization. You would launch the probe before the Egyptians built the pyramids, and it still would not have arrived. And that is just the nearest star. The Milky Way galaxy is 100,000 light years across. At Parker Solar Probe speed, crossing it would take hundreds of millions of years, longer than the entire evolutionary history of mammals. Every mammal that has ever lived, from the first tiny shrew-like creature hiding from dinosaurs to you sitting here right now, that entire story fits inside the time it would take to cross our own galaxy at the fastest speed we have ever achieved. But here is the part that most people miss entirely, and I think it is the most important part. The universe is expanding, not in the way you might picture, where galaxies are flying apart through space like shrapnel from an explosion. No, no, no. The space itself is stretching. The metric of space is expanding. And this has a consequence that is, I think, genuinely horrifying when you understand it. Distant galaxies are receding from us faster than light. Now, that sounds like it should be impossible, and I will explain in a moment why it is not. But the consequence is this. About 94% of the galaxies in the observable universe are already permanently unreachable, even if you could travel at the speed of light, even if you had infinite time. The space between us and them is stretching faster than light can cross it. They are beyond what physicists call the cosmic event horizon. And that horizon is shrinking. Every second, more of the universe slips past it. Every second, galaxies that were theoretically reachable become permanently cut off. Distance is not just an obstacle, it is an obstacle that is actively getting worse. So you might think, well, fine, the distances are enormous. But what if a civilization is clever enough? What if they build something fast enough? And this brings us to the second wall, which is, I think, the most misunderstood law in all of physics. You see, the speed of light is not a speed limit, not the way most people use that phrase. When you say speed limit, you think of a highway sign. You think of something you could break if you had a fast enough car and did not care about the ticket. The speed of light is not like that at all. The speed of light is the speed of causality. It is the maximum rate at which any event in the universe can influence any other event. It is not an engineering barrier like the sound barrier. It is a geometric property of space-time itself, encoded in something called the Minkowski metric. It is the shape of reality. Now let me show you what this means mathematically, because the math here is beautiful in a terrifying way. As an object accelerates toward the speed of light, there is a quantity called the Lorentz factor, gamma. Gamma equals 1 divided by the square root of 1 minus v squared over c squared. As v approaches c, that denominator approaches 0. Gamma goes to infinity. And the kinetic energy of the object is gamma times the rest mass times c squared. So at v equals c, the energy required is infinite. Not just enormous, not a star's worth, not a galaxy's worth, infinite. There is not enough energy in the entire observable universe to push a single proton to exactly the speed of light. And here is where I want you to really think carefully, because this is not just an inconvenience. If anything could exceed the speed of light, causality itself would break. Effects could precede causes. You could, in principle, send a message to your own past. The entire logical structure of the universe, the fact that time flows in one direction, the fact that causes come before effects, that a ball hits the window before the glass shatters, all of that depends on nothing exceeding c. The speed of light is not a punishment. It is the reason the universe makes sense. Think about that for a moment. Now, you might be thinking, okay, we cannot go at the speed of light, but what about some fraction of it? What about 10% of c or 50%? Surely a sufficiently advanced civilization could build a ship that goes very, very fast, even if not quite light speed. And this is where we hit the third wall, and I think this one is the cruelest of all. In 1903, a Russian scientist named Konstantin Tsiolkovsky wrote down an equation. It is a simple equation, and it is devastating. It is called the Tsiolkovsky rocket equation, and it describes the fundamental relationship between a rocket's speed, its exhaust velocity, and the ratio of its fueled mass to its empty mass. The relationship is exponential, not linear. Exponential. You see, to accelerate a ship, you need fuel. Fuel has mass. To accelerate the fuel, you need more fuel. And that additional fuel also has mass, which also needs to be accelerated. The fuel requirement does not grow gradually. It grows as e to the power of delta v divided by exhaust velocity. And e, the base of natural logarithms, is a merciless number. Let me give you concrete numbers, because I think numbers are the only way to feel this. Using chemical rockets, the kind we use today, the fuel mass needed to send a single human to Proxima Centauri in 40 years exceeds the mass of the observable universe. I am not exaggerating. I mean the literal observable universe. Every star, every galaxy, every atom converted to rocket fuel would not be enough. Now, what about nuclear fusion? We do not have fusion propulsion yet, but suppose we did. With fusion, the ship would be almost entirely fuel. Imagine an Empire State Building made of propellant carrying a payload the size of a toaster. And with antimatter, the most energy-dense fuel theoretically possible, you still face the production problem. Current global antimatter output is nanograms per year. Nanograms. And the cost is billions of dollars per gram. And here is the part that really matters. The energy cost of producing antimatter exceeds the energy you get back from using it. Antimatter is not a net energy source. It is an energy storage medium with terrible round-trip efficiency. You would need more energy to make the antimatter than the antimatter would give you. But there is another part of this problem that most popular science explanations completely gloss over, and it is the part that truly makes interstellar travel impossible by any method we can imagine. It is the deceleration problem. You see, it is not enough to accelerate to your target. You have to stop when you get there. And all the fuel you need for braking you must carry with you from the beginning, accelerating it the entire trip. This roughly squares the fuel problem. A ship that needs x fuel to accelerate needs roughly x squared to accelerate and then stop. The exponential curse gets squared, and an exponential squared is a number so large that it stops being a number in any meaningful sense and becomes a statement of impossibility. Now, suppose you somehow solve all of that. Suppose you find some energy source we cannot imagine, some propulsion method that sidesteps the rocket equation. You still face the fourth wall, and this one is biological. You see, the human body is a machine calibrated for exactly one environment: 1 g of gravity, 1 atmosphere of pressure, Earth's magnetic field wrapping around it like a blanket. Remove any of these and the body fails. Outside Earth's magnetosphere, cosmic rays, which are high-energy protons and heavy ions moving at nearly the speed of light, penetrate spacecraft hulls and shred DNA. A round trip to Mars, which is practically next door in cosmic terms, exposes astronauts to roughly 0.7 sieverts of radiation. That is a significantly elevated cancer risk for a trip of months. Now imagine a multi-decade interstellar journey. Without massive shielding, it is lethal. But shielding, whether lead or water or polyethylene, adds mass. And mass feeds back into the rocket equation. The biology problem makes the fuel problem worse, and the fuel problem was already impossible. And then there's gravity, or rather, the absence of it. In zero gravity, bone density drops 1 to 2% per month. The heart atrophies because it no longer needs to pump blood against gravity. Intracranial pressure rises, deforming the eyes. Astronauts on the International Space Station develop something called spaceflight-associated neuroocular syndrome. After 6 months in orbit, they need months of rehabilitation on Earth. After decades or centuries in zero gravity, the damage would be irreversible. The humans who arrive, if they arrive, would not be able to stand up under any gravity at all. Now you might say, what about cryosleep? You see it in every science fiction movie. Freeze the crew, wake them at the destination. Well, cryosleep is not real technology. Freezing living cells causes intracellular ice crystals that rupture cell membranes. We can vitrify small tissue samples using cryoprotectants, yes, but scaling this to an entire human body is unsolved and may be fundamentally unsolvable. The thermal gradients in a large organism mean the core and surface freeze at different rates, guaranteeing structural damage throughout. And generation ships? The idea of entire communities living aboard a vessel for centuries. You face social collapse in a closed environment. You face genetic bottleneck from small populations, language and cultural drift over centuries, loss of mission knowledge across dozens of generations. The humans who arrive would bear no meaningful continuity with the humans who launched. They would be strangers to the mission, strangers to Earth, strangers to themselves. And even if you send machines instead of people, you face entropy. Radiation flips bits in electronics. Micrometeorite impacts accumulate. Metal fatigues. Lubricants degrade. No machine humanity has ever built is designed to operate for thousands of years without maintenance. Voyager 1, our most distant spacecraft, launched in 1977, is already losing instruments. It has been 47 years. We are talking about journeys of thousands or millions of years. Now there is a fifth wall, and this one is perhaps the saddest. It is time itself. Humanity has been broadcasting radio waves for about 130 years. That means our radio bubble, the sphere of space that has been touched by our signals, is 130 light years in radius. Now, the Milky Way is 100,000 light years across. Our bubble is a microscopic dot. For an alien civilization to even know we exist, they would need to be inside that tiny bubble, listening on the right frequency at the right time with the right equipment. But here is the deeper problem, and I think it is the most important one. Civilizations rise and fall. Technological civilization on Earth is maybe 200 years old, if we are generous. The universe is 13.8 billion years old. The probability that two civilizations exist simultaneously within communication range at compatible technological levels is vanishingly small. Imagine two fireflies in a dark forest the size of a continent, each blinking once on different nights. They never see each other, not because they are not real, but because the timing is impossible. And there is something else: signal degradation. You see, radio signals obey the inverse square law. Power drops with the square of distance. Earth's strongest broadcasts become indistinguishable from background cosmic noise within a few light years. The romantic idea that our television signals are washing over alien worlds, that someone out there is watching old episodes of our broadcasts, that is a myth. At interstellar distances, our signals are undetectable without a receiver the size of a solar system. Now, at this point, someone always brings up UFOs, and I want to address this directly because I think it is important. Any object accelerating from 0 to Mach 20 in under a second experiences thousands of g-forces. At that acceleration, metal liquefies. Electronics flatten into paste. Biological tissue becomes a red mist. An object moving at Mach 20 through atmosphere ionizes the air around it, creating a massive plasma trail that is visible, measurable, and unmistakable on every instrument we have. None of this appears in any UFO footage. No sonic boom, no ionization trail, no thermal signature consistent with the claimed velocities. So let me ask you something. What is more consistent with the observations? Camera gimbal artifacts, parallax effects on conventional objects, sensor glare from infrared systems, or a civilization that solved infinite energy, broke inertia, cancelled sonic booms, traveled thousands of light years, and then got caught on a grainy infrared camera. The physics of arrival at interstellar travel energy scales would be unmistakable. It would light up every detector on Earth. It would not require debate. It would not require congressional hearings and blurry video. You would know. So where does this leave us? You see, I think most people hear this and feel defeated. They feel lonely, and I understand that. But I want to tell you why I think the silence is beautiful. The same laws of physics that make interstellar travel effectively impossible are the same laws that make existence possible in the first place. The speed of light limit is not a cage. It is the reason causality works. It is the reason time has a direction. It is the reason stars burn steadily instead of exploding chaotically. It is the reason atoms hold together, the reason chemistry works, the reason you can exist as a coherent structure that thinks and wonders and looks up at the night sky. If causality could be violated, effects could precede causes. The universe would be logically incoherent. You could not have memory because the future could rewrite the past. You could not have science because experiments would not be repeatable. You could not have thought itself because thought requires a sequence, and sequence requires time, and time requires that nothing outruns causality. The loneliness is the price of coherence, and coherence is the price of existing at all. Nobody is coming to save us, but nobody is coming to destroy us either. Earth is not a truck stop on some galactic highway. It is not a waypoint. It is not being watched. In a universe of silence, Earth is a statistical miracle. Life that should not exist but does. Consciousness that emerged from unconscious matter through billions of years of chemistry and accident and selection. Here on this one fragile rock, protected by a magnetic field, warmed by a stable star, isolated by distances so vast that nothing can cross them. And you know, I think there is something wonderful about that. Our imagination is stretched to the utmost, not to imagine things which are not really there, but just to comprehend those things which are. The silence in the night sky is not empty. It is full of physics, full of structure, full of laws so elegant that they simultaneously permit life and prevent it from spreading. The universe gave us everything we need to exist and made it impossible to leave. Think about that. And here we are, made of atoms that were forged in stars that died before our sun was born, sitting on a small planet, looking up, listening to silence, and understanding, for the first time in the history of this universe, why it is silent. That, I think, is not loneliness. That is something closer to wonder. And it is probably the most beautiful thing physics has ever told us.